All right, welcome everybody. Today we're going to talk about lesson number 78. This is the end of section 10.4, which is still about hyperbolas, how you would find the equation given a list of conditions, and then what I like to call name that conic. There is a long list of rules that I could give you to take any conic in standard form, multiply the A times the C, do something with the B and the D, when the truth is a little bit of common sense is really all you need. That is especially important for your take-home assessment. Remember, for the first set of problems, you have to first be able to figure out what conic it is and then find the key points. So this is going to help you to make sure that you're able to do that. This is a little bit of a shorter lesson and a little bit of a shorter homework. So if you take a look at that homework 78 below, notice that the last set of problems, 45 to 60, all they're asking you to do is name that conic. There really isn't a whole lot of work to show, if any, and you can feel free to go ahead and just use those abbreviations as needed. Throughout today's lesson, you're going to get a little chance to pause and try it. So this would be a good way for you to kind of see how prepared you are to go ahead and take that take-home assessment. And this lesson number 78 is technically the last piece of information you'll need to complete the quiz in its entirety. So it turns out the general form of any conic is ax squared plus cy squared plus dx plus ey plus f. Notice that there is no b, and there's a reason for that. We'll talk about that later in the chapter. But basically, while there are official rules for how a, c, d, etc. should behave, the truth is, if you're trying to name that conic, common sense and familiarity with the general formulas really work more efficiently and is what I would suggest. So we're going to go through these 8 examples of name that conic. I'm going to do the first 2 with you, and then I would recommend that you pause and try it, and then I have all of the solutions for you on the following slide. But again, basically, you would want to be able to look at this equation and be able to figure out, I would say, in 15 seconds or so. Certainly you could use more, but basically, can you tell me what the graph of this conic would look like just by looking at it? So your 4 choices are, it could be a parabola, a circle, an ellipse, or a hyperbola. So taking a look, the first thing you would notice is that there are, in fact, 2 different square terms. If there are 2 different square terms, we know that it can't be a parabola because a parabola only has one or the other. Then notice the fact that there is a subtraction between the 2 terms. If there is a subtraction, we know that it can't be a circle. We know that it can't be an ellipse. So therefore, we know that it has to be a hyperbola. And really, it is as simple as that. Again, there's a whole long list of rules I could give you about A times C has to equal whatever, and etc. But I would just go ahead and try to use some common sense and name that conic. So let's go ahead and try number 2. So number 2, again, your 4 choices. Taking a look at the square terms, again, the fact that there are 2 square terms is how I know that it's not a parabola, because a parabola is either or. The fact that there is an addition sign means it can't be a hyperbola, because in a hyperbola, one of them has to be a subtraction. My 2 choices are now a circle or an ellipse. Notice that in front of the x squared and in front of the y squared, there's a positive 1 in both cases. If the 2 square terms both have the same coefficient, that's how we know that it has to be a circle. So for example 3, again, I would recommend that you pause, try it, try to figure out which one it is. Example 4, look at the square terms, decide which one it is, pause and try it. Example 5, pause and try it. And again, you can just write down the letter if you're taking notes. Number 6, pause and try it. Number 7, pause and try it. Number 8, pause and try it. And here should be your answers. And again, in your homework tonight and in your notes, feel free to just write the letter. I'll know what you're talking about. But those were the 8 classifications of the conic. So if you got all 8, good for you. If not, go back and take another look. Notice I did kind of make it easy by putting the square terms all together in the front. Notice that in a lot of problems you might see on the homework, the square terms might be spread out a little more. But certainly if you were able to do these 8, you should be able to do the slightly harder versions. So now back to the hyperbola. This is just a reminder of the 4 different equations. Remember, 2 equations if the center is not at the origin, and then 2 equations if it is. Most important thing to remember about a hyperbola is that it opens towards whichever variable is positive. So notice in this first equation, the fact that the x is positive is how I know that the transverse axis is horizontal. So it's going to open from left to right. Notice how in the second version, because the y is positive, that's how I know that it's going to be a vertical transverse axis, and it's going to open bottom to top. Of course, just like the ellipse, it has to be equal to 1 in order for you to do anything. And of course, the biggest difference between an ellipse and a hyperbola is the fact that a hyperbola is a subtraction because it's essentially an ellipse that got flipped inside out. A reminder here, c squared equals a squared plus b squared. That is the equation for the foci. So again, all these equations, since the assessment is kind of going to be encouraging you to use your notes, hopefully you have all these formulas written down somewhere, or certainly you know where to access them. A reminder again of just the two different pictures. Remember, of course, that the foci are located within each of the branches outside, as opposed to the ellipse where they're inside the circular figure. Again, because you flipped it inside out. A reminder about the asymptotes, and remember, some people like to draw this box here to help them. Not required, but certainly you can if you want to. There are two different equations for how you would find the asymptotes of a hyperbola. One, if the transverse axis is horizontal, which means it opens from left to right. In that case, you're going to do b over a. If you have a transverse axis that's vertical, which means it's opened up and down, you're going to do a over b. And again, no need to memorize anything. All you have to do is refer back to these equations as needed. So really the last thing you have to be able to do here is, given a set of values, you have to be able to find the equation of the hyperbola, very similar to what we've been doing the whole time. And again, almost identical to the ellipse problems, except of course you have a slightly different set of equations. So here I'm giving you that the foci are -1, 2, and 5, 2. And I'm telling you that the vertices are 0, 2, and 4, 2. So because of that information, that is how I know that the graph is going to open from left to right, because of the fact that the foci are to the left and the right of the vertices. So because of that fact, if it's opening left to right, that's how I know that I'm using the version of the formula that has a positive x squared term. So if I know that the vertices are 0, 2, and 4, 2, that means that the center of this hyperbola has to be exactly between them, which means that the center of this hyperbola has to be at 2, 2. Then compare the center to the vertices. Because the vertices are 2 units away, that's how I know that the a value is going to be 2. Compare the center to the foci. Because the foci are 3 units away, that's how I know that c is equal to 3. And then take a look over here. So our formula for foci for hyperbolas is c squared equals a squared plus b squared. And again, because we're most often going to be solving for b squared, I just go ahead and rearrange it a little bit. So b squared is equal to c squared minus a squared. So I'm going to go ahead and solve for b squared. B squared is going to be equal to 9 minus 4, which means that b squared is going to be equal to 5. I now have all the information that I need. So again, here is my general form of the equation with the positive x term. So hk, remember that you always do the h first and the k second. So this is going to be x minus 2 squared minus y minus 2 squared. And of course, must be equal to 1. When you're talking about a positive x squared term, the a squared goes underneath it, which in this case would be 4. And the b squared goes underneath the y, which in this case would be 5. So really no harder than any of the equations we've done so far this chapter, but just a little bit different because they're for the hyperbola in particular. Let's go ahead and do number 10. So number 10, I again give you the foci and I give you the vertices because of where they are located. And again, in the homework, this is the only information that you would be given. So you would have to know that based on those, the graph would open from left to right. You would then have to know that because the graph is opening from left to right, that's how you know that you're choosing the value of the formula with a positive x term. So from here, again, try to locate the center. The center has to be located exactly between the two vertices. So between 3, 0 and 5, 0 is, of course, 4, 0. The distance from the center to each vertex is only 1 unit, which means that has to be A. The distance from the center to each of the foci is 4 units, which means that has to be C. In order to solve for b squared, I'm going to do c squared minus a squared, which means that b squared is going to be equal to 15. Okay, x minus 4 squared minus just y squared because of the 0, that's equal to 1. And again, because the x term is the positive, he gets the a squared. Because the y term is negative, he gets the b squared. And my equation gives me exactly this. Remember, feel free to work backwards. If you were given this equation, could you calculate the center, the vertices, and the foci? And that is how you would know if you were doing it correctly. One last example here. So find the standard form of the equation. And so here I'm giving you the vertices, and I'm actually giving you the asymptotes. So because of where the vertices are located, that is how I know that the graph is actually going to open vertically from bottom to top. Notice that when I chose the version, I now chose the one that has the positive y squared because that's the direction that it's opening. If you take a look at where the vertices are, the center has to be exactly halfway between the two vertices, which means my center has to be at the origin. And it turns out I don't even need to do the foci thing. So if you were to go back in your notes and if you were to look at the equations for the asymptotes, notice that this is really plus or minus 3 over 1x. If you look at the equations for the asymptotes of a hyperbola that opens up and down, that is done by doing the a value over the b value, which means that the a value has to be 3 and the b value has to be 1. So since I was able to just kind of find what a and b are, all I have to do now is square them when I put them in my equation. So I'm starting with the positive y squared, again, because it's opening up and down, minus the x squared equal to 1. And again, notice that because the center is 0, 0, that's why there's no h and there's no k. When you're having a positive y squared, that's who gets the a. So a squared is going to give me 9. B squared is going to give me 1, which means this is the nice simple equation for my hyperbola.